Welcome to The Explainer. Today, we're going to dig into a health problem that affects millions and millions of kids, costs an absolute fortune, and, it just causes a lot of pain. But what's exciting is that new research is pointing to a solution that's simpler, cheaper, and way, way kinder. All right, let's get into it.
So let me start with a question for you. When you think about the biggest, most common chronic health problems for little kids, I'm not talking about things you can catch, like the flu. What pops into your head? Maybe asthma? Maybe something like diabetes? Well, you might be surprised by the real answer. Yep, it's tooth decay, the #1 most common non-communicable disease for young children all over the world. And we're not just talking about a cavity here and there. We're talking about a serious, widespread public health issue. And look, this is not a minor thing. This kind of severe decay actually has a clinical name, and believe me, it comes with some major consequences, both for the kids' health and for the healthcare systems that end up footing the bill. So the official term for this is early childhood caries, or you'll see it as ECC, and all it means is that a child under the age of 6 has at least one tooth surface that's either decayed, has been pulled out, or has a filling. And this goes way beyond just how their teeth look. It can lead to real pain, nasty infections, and even trouble with eating or learning to talk. So just how common are we talking? Well, the data shows that a staggering 48% of preschoolers around the globe have ECC. Think about that. That's nearly 1 out of every 2 little kids. It's like a silent epidemic that's just hiding in plain sight. And the cost, wow, the cost is just as shocking. What's really wild about this chart is that jump. This data comes from a study in Latvia, and it shows that treating a straightforward case of ECC is about €86. But if that decay gets complicated, we're talking infections, pulp damage, maybe even needing general anesthesia, that cost just explodes to over €333. It pretty much quadruples. So faced with this really painful and really expensive problem, a team of researchers in Latvia decided to tackle a huge question. Is there a better, more affordable way to stop this decay before it gets out of hand? And that brings us to this no-carie study. So here's what they did. They got together 371 preschoolers who already had pretty bad tooth decay. They then tested 2 different non-invasive treatments, one called silver diamine fluoride, or SDF, and another called tephine fluoride, and they compared them to a placebo. But here is the really clever part. They tried them out using 2 totally different schedules, and then they just sat back and tracked everything, costs, health outcomes, for a whole year. Okay, let's break down these 2 schedules, because this is the heart of the experiment. The first one was called intensive. That meant they packed 4 treatments into just 1 week, once a year. The other approach was biannual, which was much more spread out, just a single application every 6 months. So the big question was, which is better? Do you hit the problem hard and fast, or is slow and steady the way to win? Well, after a full year of tracking every cavity, every complication, and every euro spent, the researchers had their answer. And honestly, the results were so clear. One strategy was the hands-down, no question about it winner. So what's your guess? Was it the all-out intensive blitz of treatment, or the more relaxed, twice-a-year approach? And which of those fluoride treatments do you think really made the difference? Now, before I show you the numbers, we need to know this term, a dominant intervention. In the world of health economics, this is basically the holy grail. It's when you find a treatment that not only works better at making people healthier, but it also costs less to do it. It's the absolute ultimate win-win. And that's exactly what this study found. And this table just lays it all out perfectly. Let's start at the top. The placebo group ended up costing almost €288 per child, mostly to fix all the complications that came up. The runner-up, tephine fluoride applied twice a year, was way better. But the clear winner, right there at the bottom, was silver diamine fluoride, SDF, applied just twice a year. It had the lowest total cost by a long shot, only €126, and it delivered the biggest health benefit, saving over €160 in future costs. The researchers themselves couldn't have put it any better. Right there in their conclusion, they state it flat out. Applying SDF twice a year was the single most cost-effective way to deal with ECC. It wasn't even a close race, so if you want to boil it all down to one number, this is it. For every single kid who got the biennial SDF treatment instead of the baseline approach, the health system saved, on average, €163.50 in just 1 year. That is just a huge win. Okay, so a scientific study found a clear winner. That's great, but what does that actually mean in the real world, for kids, for their parents, for how we run our health systems? Let's zoom out and look at the big picture here. So let's just recap the biggest takeaways. First, less is more. The simple twice-a-year schedule totally beat the intense week-long one. Second, silver diamine fluoride, SDF, is a real champion for this kind of problem. Third, this approach saves a ton of money because you're preventing all those expensive complications down the line. Fourth, and this is the most important one, it prevents pain and suffering for these kids. And finally, here's a cool little side note. Just showing up for regular counseling visits helps, even for the placebo group. It shows that just consistent contact with a professional makes a difference.
And that really brings us to the final thought here. The evidence seems pretty overwhelming, right? We have a treatment that's non-invasive, it's cheaper, it means fewer visits, it stops kids from being in pain, and it saves the entire system money. So the big question we're left with is this: what's stopping us? What are the barriers that are keeping this research from being used for the millions of kids who could benefit from it right now? Thanks for joining us on The Explainer.